For the toolpaths that use constant Z-cutting, those are core roughing, area clearance, and waterline finish. We have the ability now with surface high-speed machining to use adaptive step-down. Those constant Z-cutting toolpaths tend to work very well in steeper portions of your part, such as 30 to 90 degree walls. However, when you get into more shallow areas, they tend to leave very large stair steps. Let's take a look at machining this part with an area clearance toolpath. I go into my parameters. We can see I have 1/8 of an inch step down, and my adaptive add cuts feature is turned off. We'll go ahead and verify that. And my part here has step down passes equal to 1/8 of an inch. On the vertical areas of my part, that finish may be okay. However, shallow areas, such as this very shallow fillet down here, I get very large stair steps, which leaves a little bit too much to clean up. If we go ahead and backplot this toolpath, turn my shading to translucent, and we'll look at it from a side view here. You can see that each step is equally 1/8 of an inch apart. Let's go ahead now and take a look at the adaptive step downs. Here I'm going to select the Add Cuts button, and the values that I have keyed in here allow my tool to make a minimum step down of 25 thousandths of an inch. So my step down will be between the range of 0.125 and 0.025. Let's go ahead and regenerate that and verify. And you can see here I have a much more consistent profile of my stock here, especially in the shallower areas where Mastercam configured a shallower step down for me. We can go into backplot here with a side view, and we can see that my tool is taking a large step down in the steeper areas, but as it gets down to the shallow areas of the floor of my pocket, the tool is taking progressively smaller step down. So how does it configure what size step down to take? Well, it always tries to take the largest step down possible. But if we go into our parameters once again and take a look at the max profile step over, this value here is the width of the stair step left on my part, while taking a step down somewhere between 0.125 and 0.025. Now, the stair step may get larger because it cannot take a step down any smaller than 0.025. So for example, let's reduce this value to 5 thousandths of an inch. Click OK and regenerate. Let's go and verify. These stair steps here are even smaller than the previous verify, because now our value is 5 thousandths of an inch stair step, whereas the last stair step size was 16 thousandths. So even up on the steeper walls of my part, Mastercam forced a very shallow step overs to maintain that 5 thousandths stair step value. We can see that in the back plot, side view again, and throughout just about the entire part, we took very shallow step downs. That's because our value here of our max profile was 5 thousandths of an inch. Let's go the other way now and change this value to 50 thousandths of an inch. Regenerate, and now we'll back plot again. You can see now this is taking the full 125 step down at the top of the part, but then in the bottom here moves down to the shallower step down value. Go ahead and verify that, and we can see the result. So in summary, by having add cuts selected and using the adaptive step down values, you can create a happy medium between large step downs for aggressive cuts on steeper areas of your part, and then minimum step over and the profile of your stair steps to create a finer roughed part in these shallower areas.